Heya, I'm Emily, and let's dive into Peto's paradox. What is it, and how can understanding its theories help us combat cancer in the future? In 1977, epidemiologist Richard Peto believed that larger animals should be at greater risk of developing cancer because the more cells means a greater possibility of mutations. This is a graph of Peto's paradox. It shows how larger animals have a greater expected cancer rate, but the observed cancer rate is much lower. Let's quickly observe how cancer happens. As cells mutate, there's a chance for them to develop a mutation. After each mutation, the cell gets progressively more harmful for the human body until it starts thinking on its own and becomes a cancer cell. There are two main theories that can explain this, but I'm going to focus on two of them: evolution and hypertumor theories. Let's start with evolution. As time went by, animals got bigger and bigger. Of course, bigger animals have more cells, which led to more chances of mutation. Creatures had to adapt ways to combat this, and in the form of tumor suppressors. As you can see from my little diagram here, that with more cells, there's more chances of tumor suppressors, which helps combat these cancerous cells. Now, tumor suppressors serve as a brake for proto-oncogenes. As long as the tumor suppressors are effective, the proto-oncogenes are regulated to prevent mutated genes. Bigger animals have more tumor suppressors, as I mentioned earlier, which means they need more mutations to develop a cancerous tumor that is dangerous for the animal. The other theory I will discuss is hypertumors. Now, hypertumors are tumors that prevent other tumors from growing and becoming dangerous to a species' health. They are similar to hyperparasites, which are parasites of a host that is also a parasite. It's kind of like a stack of parasites, where you have a parasite on a parasite over a parasite of a parasite. Now, let me show you how this concept relates to tumors. As a tumor grows, there's a chance for a cancerous cell to rebel and begin leaching resources from the original tumor. And the hypertumor grows. The original tumor cannot gain enough resources to keep it alive, which results in the tumor dying. This process continues over and over, which prevents the tumor from escalating and causing damage to bigger species. Now that we know a few theories, what can this lead to? Well, they can help scientists understand cancer resilience and open doors to discover new treatment and therapies. Now, I do hope that scientists can figure out how to find genes that play a role in tumor suppression and create a treatment that mimics that process for humans, or that scientists can find a way that is similar to hypertumors and fight cancer with cancer. Peto's paradox is a wonderful concept to help us research and test theories to combat one of the deadliest diseases.